Have you ever thought about traveling through time? What if you could journey into the future or revisit the past? Picture this, a world where time is not a constraint, but a variable, an elusive concept that has fascinated humankind for generations. It's been the subject of countless stories, movies, and theories. We've seen the likes of H.G. Wells' Time Machine, Doctor Who's TARDIS, and even Marty McFly's DeLorean. Time travel has been a captivating concept for centuries, but is it really possible? Believe it or not, science has something to say about time travel. Let's delve into the captivating world of scientific theories that have opened doors to the possibility of traveling through time. One of the most prominent figures in this field is none other than Albert Einstein. His groundbreaking theory of relativity, proposed in the early 20th century, has been a cornerstone in our understanding of time travel. Einstein suggested that space and time are intertwined in a four-dimensional fabric called space-time. He proposed that massive objects like planets and stars create distortions in this fabric, causing what we perceive as gravity. But how does this relate to time travel, you might ask? Well, Einstein's theory also suggests that the stronger the gravity, the slower time moves. This concept is known as time dilation, and it's one of the key elements that could, theoretically, enable time travel. Imagine you're on a spaceship traveling near the speed of light, far from any significant gravitational field. According to Einstein's theory, time would pass more slowly for you compared to someone standing still on Earth. To put it simply, you would age slower. If you were to return to Earth after your space journey, you might find that while only a few years have passed for you, decades or even centuries may have passed on Earth. This is not just a theoretical concept, it's a proven fact. Experiments with precise atomic clocks on airplanes and satellites have confirmed time dilation. Clocks on these fast-moving vehicles tick slower compared to those on Earth. However, it's important to note that Einstein's theory doesn't provide a practical method for time travel. It merely sets the stage for the possibility. Time dilation only works one way. It allows you to travel into the future, but not the past. The concept of traveling back in time introduces a whole new set of problems and paradoxes, which we'll delve into in the next segment. So we see that time travel isn't just a figment of our imagination, but has some scientific basis. Time travel may sound exciting, but it brings its own set of problems. Among these are mind-bending paradoxes that challenge our understanding of reality, time, and causality. Let's delve into two of the most famous paradoxes, the grandfather paradox and the bootstrap paradox. Imagine, if you will, that you've built a time machine and zipped back to a time when your grandfather was a young man, long before your parents were born. In a tragic twist of fate, you accidentally cause his demise. Now here's the paradox. If your grandfather passed away before your parent was born, then you wouldn't exist. But if you don't exist, who traveled back in time to cause the accident? This is the grandfather paradox, a classic example of the potential problems time travel could create. But hold on, it gets even weirder. Let's move on to the bootstrap paradox, named after the phrase, pulling yourself up by your bootstraps. This paradox deals with objects or information that exist without any discernible origin. Suppose you're a scientist in the future who builds a time machine based on plans you found in an old book. You travel back in time and leave the book for your past self to find. Now here's the catch. Who wrote the original plans? They seem to have come from nowhere, creating a closed loop with no discernible beginning or end. These paradoxes aren't just fun thought experiments. They present real challenges to the concept of time travel. They question our understanding of cause and effect, suggesting that the past, present, and future might not be as linear as we think. They hint at a universe where time can fold in on itself, creating loops that defy our common-sense understanding of how the world works. These paradoxes leave us wondering if time travel could ever be a reality. But don't worry, there's still plenty more to explore in this fascinating field. So, buckle up as we journey further into the enigma of time travel. Even if time travel were possible, it would have its limitations. Let's first tackle the physical limitations. According to our current understanding of physics, time travel isn't as simple as hopping into a DeLorean and hitting 88 miles per hour. It involves the manipulation of space-time, the very fabric of the universe. To do this, we would need to create a wormhole, a shortcut through space-time. However, to open a wormhole and keep it stable, we would need something called exotic matter, a theoretical substance with negative energy density. And as of now, we have no evidence that such matter exists. Next, we must consider the technological limitations. Even if we did have all the exotic matter we needed, we would still have to build a machine capable of creating and controlling a wormhole. That's a tall order. Our most advanced technology today is nowhere near capable of this feat. It would be like asking someone from the Middle Ages to build a spaceship. Then comes the energy requirement, which is colossal. To give you an idea, it's estimated that to open a wormhole just 1 meter wide, we would need the energy equivalent to that produced by a star over its entire lifetime. That's a lot of energy. And we haven't even begun to discuss how we would harness and control such an enormous amount of power. Finally, there's the issue of safety. Traveling through a wormhole might be like navigating a stormy sea, with violent fluctuations in gravity and time. It could be a one-way trip, with no guarantee of a safe arrival or return. And then there's the risk of causing catastrophic changes in the past or future. These limitations remind us that time travel, while fascinating, is fraught with challenges. It's not just a matter of building a time machine and hopping in, it's a journey into uncharted territory, a voyage into the unknown. And while the idea of traveling through time is tantalizing, we must remember that it comes with a host of problems that we are yet to solve. Despite these challenges, the quest for time travel continues. The future is a fascinating concept, especially when we consider the prospects of journeying there and back. As we speak, the gears of scientific inquiry are turning, delving deeper into the mysteries of time. A key player in this exploration is quantum physics. This branch of science dances on the edge of reality as we know it, and it's here that we could potentially find the keys to time travel. Quantum physics explores the behavior of particles at a microscopic level, and it's a world where the rules of classical physics don't always apply. Some theories suggest that time travel could be possible within the realm of quantum mechanics, although we're still a long way from understanding how. Another area of study that could unlock the secrets of time travel is the concept of wormholes. These are hypothetical shortcuts through the fabric of space-time, and if they exist, they could potentially allow us to travel great distances in an instant, or even move through time itself. The challenge, however, lies in finding and accessing these elusive wormholes, and of course, surviving the journey. While we may not be packing our bags for a trip to the past or future just yet, the dream of time travel lives on. The pursuit of knowledge continues, and who knows what fascinating discoveries the future will bring. So there we have it, a journey through the fascinating world of time travel. We've delved into the captivating enigma that it presents, a concept that has intrigued and inspired humanity for centuries. We've touched upon the rigorous science behind it, from Einstein's theories to quantum mechanics, revealing the tantalizing possibility that time travel might just be within our grasp. We've wrestled with the paradoxes of time travel, those mind-bending conundrums that challenge our understanding of reality. We've explored the limitations, the barriers that stand in our way, and the monumental hurdles we would need to overcome. And let's not forget the future of time travel, a realm of endless possibilities and potential, a horizon that stirs our collective imagination and drives our relentless pursuit of knowledge. While the reality of time travel remains uncertain, one thing is clear: our fascination with it is timeless.